First, we're going to calculate the energy release of Tsar Bomba. You can look up the amount of release in Google, and you'll read that it's 57 megatons. Well, we have to deconstruct megatons. Let's look at mega. Mega means a million. And so a million is 1 with 6 zeros. That's not very convenient. We want to use a mathematical notation for that. And we'll write it as 10 to the power 6, which means we multiply 10 by itself 6 times. So that's the mega part. Now we got T, the ton part. Ton of what? Tons of TNT, equivalent energy release. We'll play with the numbers a bit later. First thing we have to do is write 57 megatons using our powers of 10. So 57 megatons is 57 times 10 to the 6. 57 million tons of TNT. Let's look further at the yield. It's 57 times 10 to the power 6. First thing I want to do is I want this number to be an order 1 number, meaning a number between 1 and 10. I don't want the 57. So I'm going to write 57 is equal to 5.7 times 10 to the power 1. If I multiply 10 times 5.7, I get 57. So now let's put that in the yield description. So we get 5.7 times 10 to the power 1 times 10 to the power 6. And these are all tons of TNT. Now what do I do with this? This is not very convenient. I have this sort of tail, times 10 to the 1 times 10 to the 6. Well, we know that 10 times a million is 10 million. That's 1 followed by 7 zeros. Well, if I just add the powers of 10, 1 plus 6, I get 7. And there it is. Now, for a lot of you, this may seem rather trivial, but we've done something very deep here. We've taken multiplication and actually calculated it by doing an addition. Something we're going to revisit many, many times as we look at nuclear weapons. Continuing in our energy calculation at Tsar Bomba, we just had the yield. There it is, 5.7 times 10 to the 7 tons. Now, every ton of TNT releases how much energy? Well, I don't know. Let's go to Google. And Google says that 1 ton of TNT releases 4.2 times 10 to the 9 joules. That's a lot of joules. The total energy is the product of the number of tons, 5.7 times 10 to the power 7 times 4.2 times 10 to the 9. And that's all going to be in joules. Let's finish this calculation. Here's our product of the two numbers we need to multiply. First thing we do is we rearrange the order so all the numbers less than 10 are together. So we have 5.7 times 4.2. And let's deal with the powers of 10. We know how to do this. When you multiply and things are expressed in powers, you add the exponents. So we're going to be adding these exponents. Add them together. 7 plus 9 is 16. So this becomes 10 to the power 16. Well, now we got 5.7 times 4.2. What do I do with that? Well, first thing you do is you approximate. 5.7, good enough, 6. And 4.2, good enough, 4. Well, we know what 6 times 4 is. It's 24, which we can also write as 2.4 times 10 to the power 1. So we have 6 times 4 times 10 to the 16. We write 24 as 2.4 times 10 to the power 1, and we get 2.4 times 10 to the power 1 times 10 to the power 16, which gives me 2.4 times 10. Add exponents again. 1 plus 16. 2.4 times 10 to the 17. You say, well, wait a minute, you approximated it. What is it really? Well, if we actually go to a calculator and do this, we'll get 2.39. Pretty good for approximation, eh?